Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are in the midst of adding a couple features to our memory arena here. Yesterday we did the basic step, after I explained kind of the concept of it, of allowing our memory arenas to expand dynamically as necessary in case that is a feature that you want to use. But although that works just fine, we have not allowed that to, we basically haven't implemented support for two other features that we have to work concurrently with it. The first one being temporary memory usage. So basically when you take a memory arena and say, I'm going to do some work in this arena and I don't want you to save what I'm about to do. So I'm going to do a bunch of allocations, but then I want you to kind of undo all those allocations as a block later. We're not supporting that correctly right now. Technically, it would work occasionally, but at any time you were to cross one of those dynamic allocation boundaries, it would fail. And the other thing that we are not currently doing in a way that would necessarily work correctly is the dynamic, the sort of looped live code editing stuff, where you can sort of, the live code editing part will work fine, but the looped part, the part where you can like return to a previous state of the program, that is not currently possible anymore with this system either, because the memory arenas that are set to dynamically grow will not restore properly at the moment, right? And the reason for that is because they are not currently being tracked in any way. So when that system goes to save out memory and restore memory, it doesn't know about those extra arenas. So obviously it's not going to be able to make them function properly, right? So that's what we have to do at the moment. And the first one is pretty easy to do, so that one we'll definitely do today. Depending on how smooth that goes, we could start on the second one, but the second one's going to be a little bit more involved. It's not particularly difficult to make dynamically growing arenas work with looped live code editing, but it is more code. And the reason for that is because inside the loop that's being done for the live code editing, you may have a situation where some memory arenas have expanded. And so when that happens, you have to be aware of that. And when you go back to sort of the original state of the program, you have to be aware that those things happen and free those, assuming that you don't want to leak memory during the loop, right? So let's go ahead and get started. Today is day 342. If you want to follow along at home, if you're trying to follow along with the source code yourself, you'll want to use day 341 source code. That is what I'm starting with right now. Let's go ahead and boot this up here. You can see that we're still actually, even though we haven't implemented those features, we are still running properly. We're not noticing an error of any kind at the moment. And that's because we're not actually marking any of those arenas, those the ones that are actually involved in temporary memory use. We're just not happening to hit those because we only set one of our memory arenas to be a dynamic arena. So we're not actually seeing any obvious bugs at the moment. And even if we did loop live code editing, we might not, right? It still works. And the reason that it still works is because, again, the only arena that we actually marked as dynamic was one from the debug system. And so the fact that that arena isn't getting restored properly isn't causing any obvious bugs, right? So the whole program is working currently, but it's not actually technically supporting the arena stuff. It just happens to be that we aren't using the dynamic arena support in any place where it would have actually caused an actual bug, right? So that's the reason why we're not getting that, why we're not seeing any deleterious effects here. But we should be able to provoke some of these deleterious effects, like the temporary memory one, by taking a look. Actually, we could start here and just say, when we say begin temporary memory, you can see right here we do this begin temporary memory. If we were to go find an arena where that was happening, right? So for example, here is one in Handmade in world mode, right? And you can see temporary memory doing this on the transient arena here. So if we were to do it on this sim memory guy, we could probably provoke a bug here, right? And the way we would do that is this transient arena, if we went ahead and said that the transient arena, instead of having been a big block that was allocated out of stuff, we could instead go ahead and make that be an arena that was dynamically growing, like our other one. And if we did that, we should be able to provoke an error here, or something, a crash, bad behavior, or something bad happening, by forcing it through that path, okay? So let's just try. Let's see what happens if we do that. There's also something that I would like to take a look at possibly as well, which is that right now we have this concept that arenas, you can say how much room there is left in them. Let me see where that actually is. Get arena size remaining. And people have been using that kind of to figure out what they can do for sub-arenas, right? And you can kind of see that happening, like here, no, not there. Here, you can see that happening. When we create the world and we get an arena that's our parent arena, we go ahead and say whatever's left in there we're going to use, right? And again, that's something that we probably want to stop doing. If we start using dynamically sized arenas for stuff, we can't really do that anymore, because if you ask a dynamic arena how much size it has remaining, it could answer anything. It's just about the block that it happens to be in. So it's not a good thing to use, because it could answer like 4 bytes, right? I mean, who knows how close it is to the end of its particular block that it was using. And so when we do stuff like create world or something like that, and we say parent arena, all we would really want to do there, if we're doing sub-arenas off of things, is we'd want the sub-arenas to be things which were tied to the parent arena. So when the parent arena got cleared, the sub-arena would get cleared. That's about the only thing we would actually want to do there, right? But we wouldn't want to keep doing that get arena size remaining stuff. That's not particularly helpful for us. Fortunately, it looks like that's really the only place that we're using it, is inside that sort of mode world thing. And those are not in the transient arena. So for the moment, we can actually leave that and not have that do anything in particular. But now I'm going to go ahead and I'll do some sort of surgery here on this code, and I'll go ahead and eliminate that transient memory pool that we were using before, and we'll switch that to a dynamic arena as well, right? And so here we are with transient storage. And we'll say, OK, the transient storage size stuff, let's get rid of that and just say, actually what there is there just one of those transient states. Let me see where that is. Handmade.cpp, transient state. So we can just have one of these transient state things. And again, instead of an is initialized, we'll just say that we store a pointer to that state, right? So in the game memory structure, we'll say, hey, we know you're going to want some transient state struct. We don't care what it is. You define it yourself. The platform part of the game doesn't care what it is at all. But we know you might want to do that separately or something like this, so we'll have the pointer in here. And actually, honestly, we probably can collapse these down eventually too. Once we can just have one structure, which is just like the game's, the actual game struct, which could contain the transient and non-transient, because now that we allow previously we had only push forward for memory. Now that we're going to say there's no more push forward for memory, the app can request memory. It is something the app can request. Then we don't have to do that anymore. The only reason to have everything pass forwards is just in the case where you don't want the app ever allocating any memory. You don't want to support that callback, right? Which is a totally valid thing to do, again, like I said. But once you say, I can support growing arenas, then that means you have to have an allocate and deallocate callback. So once you have those, there's no reason anymore not to just have the app do those initially. So now the app, even if the application wants to run in a completely restricted memory space where it's only going to use a certain amount, it would still just at startup, the app will do the allocation of the 2 gigabytes of memory or however much it decides it's going to be its space. It would make that call rather than the platform layer making that and passing it forwards. So yeah. So basically, this would just go away here, right? And now we would just have a thing that was the transient state. And then we'd have to basically do the work here of making sure that that transient state was always accessed that way. I don't know debug get main generation ID, debug get game assets. Really want to get rid of main generation ID. Yeah, we probably do. But hey, we haven't yet. But that's okay, because that means this transient state call, again, is it's really just this now. And it's kind of nice because it means that we no longer have to do any of this stuff, right? We can sort of just access this directly, and it's actually kind of cleaner than what we had before even, which is nice, right? So then here, when we're doing transient initialization, again, the exact same thing's going to happen here that we were doing before. So in the debug state, if you remember how we did this, we sort of did the memory arena little shuffle, right? We did this sort of idea that you create a memory arena, you push on the struct you actually wanted, and then you sort of record back to the structure that you had, whatever the state of the arena was, right? And so that's such a common thing that we want to do on startup that we can probably make it into some sort of a reasonable utility function. It's a little bit squirrely just because C is really bad at these sorts of things. C really doesn't like you to use pointers to things that don't exist yet. The syntax just isn't as amenable to it as you would like, even though it's a very straightforward thing to do. But you can imagine what we're talking about here. So let's suppose that I have a function that looks like this. Bootstrap push struct, right? And we'll call that actually push size, because we're going to have a macro here just like we have a macro for push struct. So if we do bootstrap push size, what we need to do is say, all right, we know that there's some kind of a size. And I thought I added this, right, nowadays, so I don't have to use memory index anymore. I should probably replace memory index. I like these are more concise, in my opinion. I did add those, right? Yeah. So when I do bootstrap push size, what I need to know is, like, okay, how big was the thing that you wanted to push on there, right? And what I'm going to do is I'm going to create a new arena from whole cloth, but then I'm going to push on something that's going to contain the arena. So the other thing that I need, right, is the offset. So I basically need an offset to arena inside the main struct, right? So however far over that is. And so then what I can do is I can say, all right, I know I need a new memory arena, right? And it's basically now just this code. I know I need a new memory arena. So I'm going to create one. I'm going to bootstrap it by pushing on whatever the size is that you actually told me to push on, right? Or this is the struct pointer, basically, right? This is what I pushed on. And then I want to do this exact operation here, right? I want to say that the memory arena that's inside the struct I just created in the memory arena itself, I want to put the memory arena in there. I want that to be the thing that tracks it. But I can't just write that because I don't know what the struct actually is, right? So what I have to do is just say, well, okay, pretend we had a memory arena pointer, right? If we had a memory arena pointer, where would it be? Well, it'd just be whatever the struct pointer was plus whatever the offset is that you told me. That's where it would be, because you just told me that's how far over it is. So pretend that's a memory arena and write it in there, right? Then, of course, return the structure to the person who actually wanted it in the first place. So it's not very complicated, right? It's pretty simple code. It's just a little bit squirrely because of the syntax. And then again, for the bootstrap, ness of it all. Oh, and I should also allow you to align that if you want to, or do other things like clear. So in that case, we do want the arena push params in here. So I want to be able to pass params, and those will just get passed through to the size. Right, so now we can do a bootstrap push struct and a bootstrap push size call as a result. And now we have the ability to do this inside like say the debug system as well, right? So now we can just do, okay, instead of all of this nonsense here, I can just say debug state is going to be bootstrap push struct of the exact same thing that I called before, right? And so the only thing I have to do now is actually get an offset of, and I feel like we have an offset of, right? Yeah, we do. So I just need the debug state's debug arena. That's how far over I want, that's where inside the debug state struct it goes, right? And that's it. So yeah, so the same thing would happen here. The transient state structure, right, which is going to get written back into that, into the game memory structure there. Excuse me. Okay. What I want to do here is say, all right, let's take the transient state that I wanted to write, and we'll store the transient state here as well inside the memory struct, just so that it's persistent across frames. What I want to do again is do a bootstrap push struct, right? The bootstrap push struct will just pass one of these. We'll just do one of these guys, right? And we want the transient arena on there as well, so we want to do an offset of the transient arena, right? And again, we only actually want to do this operation if we have to, right? So if the transient state already existed, right, we wouldn't need to do this. So, you know, really this kind of thing, this part actually kind of goes down here. It's like the trans state. Just put it up here, actually. We could do the trans state equals the transient state on the memory structure. If that is not valid, then we will initialize it. Otherwise, we pass through. Right? So it's just very simple. That's about it. We do the bootstrap, and then off we go. We don't need to do any of this initialization stuff at all, because now we just have an arena, right? And that's it. So the only other things that we probably want to do here is when we do the bootstrapping initially, we probably want to have the bootstrap push size, unlike everything else. We probably want this to be like, there to be some additional information here. So there'd be like a struct size, but there'd also be, and maybe the, you know, that offset arena, but then there'd probably also be the minimum block size bit, because when we do the bootstrap, we'd probably want to set that minimum block size as well. And that can just be set to 0 by default, but then if somebody wants to, they can set that minimum block size to something else, right? And these should be set to the default params as well. So that's about it. I think that's it. Now we just have to clean up some of the other things that need to be cleaned up. Oops. What's the problem here? Syntax error. What is the syntax error? Will you tell me? Size of type. It's arena. Just forgot to get rid of the arena there. So the bootstrap push struct actually still needs the offset bit. I suppose we could just make it, since we know that we're going to do an offset, we could just do it that way, right? So that you actually just pass in the member that you're talking about. And so that would just be like, okay, we're going to do a bootstrap push size of the type and the offset of the thing from that type. And that's the only part that we need the macro for. The rest can just be var args that are passed along. So I think that's it. Bootstrap push size, don't know why I put a... Oh, probably because we want to maybe also keep one of the... Do we actually need that to be an underscore for any particular reason? Why did we do that? Is there a push size macro? Oh, yeah, because we probably want to pass debug data sometime. So we probably should keep that convention in place and do it that way. All right, so transient storage. when we do get sound samples and output playing sounds, that, again, is just going to be able to do it exactly the way that it was. So nothing really happening there that's unusual. This guy just now has to conform to the original way we were doing things. Transient storage size no longer needs to do anything at all. Let's take a look here. Permanent storage size for transient storage. So now this, again, gets a little bit simpler. Off we go. And transient storage doesn't have to happen. I think that's basically it. Nothing else to it than that. So let's now take a look at what we've got. Presumably, and yeah, OK, so this was what we were sort of hoping for, although I don't actually know that this is. We may have introduced another bug, but like I said, begin temporary memory and end temporary memory were the things that we were trying to provoke a bug in. And so hopefully that is actually what we did. I don't actually know, though, because we have not actually verified that that's what we're looking at yet. So let's take a look. So arena used, temp mem used. So yeah, I assume this would be pretty much exactly what we would have expected to see, right? We come in here and the memory arena has gone through some kind of a allocation event, and now you're trying to unwind, but you can't unwind properly because this arena has actually changed its base pointer and its state because it allocated a new block. And so this assertion is firing and saying, hey, wait a minute, what's going on? You're trying to rewind something that wasn't even that far to begin with. You know, what's the deal? OK. So that's good. That's what we wanted to see. But now the question, of course, is what are we actually going to do about it, right? So I provoked the bug that I said that I wanted to provoke. But we're going to have to come up with a solution because we obviously can't, we obviously can't leave it in such a fashion as to not have our temporary memory stuff working. So let me just briefly explain what we're going to do. Again, like I said before, it's actually very simple. Oops. So this is like temp mem for dynamic arenas. So if you followed yesterday's stream, then you know that how we implemented this is we take our normal arena that we had before. It has its base pointer. The base pointer has like a used count that comes up. So we move that sort of logically down until we get to the end, and we'll try to push something on the end that would overflow. Instead of just asserting, which is all we had in there before when we had fixed size blocks, now what we do is we allocate a new block, and the new block, right, we can then point to the beginning of it and use it again. So the question is, how would we implement temp memory? Well, if we wanted to implement temp memory, then obviously one thing we would have to do here is we would have to have a way of knowing that this had happened. Because if the temp memory gets locked right here, so it says, hey, I'm going to begin a temp memory thing, then we do some stuff and we push a new one on and we end like here, right? So we filled up all of this with temp memory. Then what we need to do is we need to eliminate this block. So we need to free this block back to the system. And we need to jump back here, right? And so what we need to do is we need some recollection in our system that this situation occurred so that we have something we can do about it, right? We don't, at the moment, we don't have enough information to really do anything about it, and that's a problem. Well, what we can do, right, is use a very simple chaining scheme. If we want to, we can just say, well, all right, if we took these memory blocks, for example, and we just said at the end of the memory block, when we allocate one, we're just going to put a pointer right back to the previous memory block. Then, if we wanted to, we would be able to know when we said end temporary memory, we'd be able to know that there was a situation that we might need to be aware of where there's a previous block in the mix, potentially multiple of them, right? These could keep going. So then what we can do is say, well, whatever the pointer is, right, that we were trying to rewind to, is it inside our block? If it is inside our block, we just do exactly the same thing we did before and restore the used pointer. If it's not, free the block we're on and set our memory arena to the previous block, then try again, right? That's really all we need to do, because eventually that will walk back to the very first block and, find somewhere along the way, or at that very first block, the actual original temp pointer. And when it does, then it'll stop. That's it. So like I said, very, very simple, actually. There's just a little finickiness with it, and it has to do with how you actually specify where things are in the block, how you put the footer on, and that sort of thing. But let me go ahead and show you what I mean. So if we say memory block footer, and we take a look at what this is, all we really need to know here for the memory block footer is, okay, we need to be able to restore the previous memory arena if we free this block. So the things we don't know about them is we don't know what the size was, right? We don't know what the used count was, and we don't know what the base pointer is, right? We just don't know what those values are. So if we just stuck these things into the footer, like so, then we could fully restore the information that we needed, if that makes sense. That's all there is to it, really. So now, we just have to make sure we put this thing. I'm going to, by the way, make this memory block footer. I'm going to make it exactly 32 bytes just because. So anyway, here's our memory block footer. That's going to kind of just, be something that's stuck on the end there. If we wanted to, we could sort of compress this down a little bit. We could make it only 64 bytes, because if we wanted to, we could say that we were only going to track, 4 gigabytes of size per block, right? Because, presumably we're not going to be allocating chunks that are bigger than that. We're always going to be allocating things that are smaller than that. So who knows, right? But if we go ahead and see memory block footer, right, there's our one here. We can just say, all right, doesn't matter, it's however big it is, whatever, blah, blah, blah. I'm not going to bother padding it. I changed my mind. Anyway, so we have that memory block footer. What we need to do now is be able to actually stick that memory block footer onto the end of things, right? And so when we go ahead and do our sort of fail down procedure, so like when we do a push size here, what we want to do is say, all right, when we allocate one of these new blocks, we need to be able to stick the footer onto the end of it, right? And so when we take a look at what the size is that we're actually going to allocate, we don't want to use that as the actual size, right? What we want to do instead is say the size plus the size of the footer, because that is the minimum when we, when we allocate a block to store whatever the new push is. Either we're going to do the minimum block size, which we know will have room for our footer because we know that a megabyte is bigger than however big our footer is. But if someone asks for a size that's bigger than a megabyte, so we need to allocate a block just to store this one thing because it's huge, then what we want to do is make sure we could fit the footer on the end and still give back the person who's requesting it. We want to still be able to give them back the size that they asked for, right? So now we know we have enough room for our footer, right? And we know, furthermore, where the footer is going to be. Now, when we then set the size of the arena, we don't want to include the size of the footer, because the footer is reserved. It can't be used as an allocation, as a thing for allocation. So we need to then, the memory giveth and the memory taketh away here, right? We got to add room for the footer, and then we have to pretend we didn't have room for the footer when we're done. Okay. So then, once we're done, where is the footer? Well, we know where the footer is, so we can just make a thing that gets us back the footer, right? If we have memory block footer, if we were to pass a memory arena and say where is the footer, we know where the footer is because however big the size is of the arena, if we went that far off the base pointer, we're at the memory block footer, right? Because we know we set the size to be however big the block was, less the size of that footer. So we know that the footer is here, and so we can get that footer. Right? So you can see what I'm doing. I'm just taking the base pointer of the arena, and so that gives me back the memory block footer for the block that I'm currently on, right? Whatever that block is. So then what I can do is say, all right, I need to set up this footer to allow me to back up. So what I want to do is say, give me back the footer. Here's me getting my footer back, right? Get footer. So there we go. And then inside the footer, I want to record the information that I was going to lose, right? So I need to be able to say here in my, where is my footer here? Here we go. So in my memory block footer, and I suppose the other thing, I could sort of do this as a pointer thing. I could do this sort of separately. I'm not sure how I really want to do it. I'm going to do it this way. So I'm just going to say, all right, let's save all the information from our arena. And then we'll just do, right? So that'll take all of that information, and it will save it to the footer in this new block that we've allocated, right? Now, in theory, in theory, that should just work, right? Oops. Force of habit. All right. So in theory, that will just work, right? We will just stick that information in there. So now every time we allocate a new block, it will put that information into the memory block footer, and we're good to go, right? But there is one caveat here, which is that if we were in an arena that did not allow for dynamic allocation, right, its initial block would not have had this property, right? So we wouldn't be able to get the footer out of that block, that first block that was there. So if we want to technically be, you know, I don't know how you would look at this, but if you wanted to be a little safer here, what you'd want to do is say, well, I mean, I guess it won't matter because it'll just crash or something. But basically what I'm saying is we could add a safety check here that says when you get into this part of the code, you want something that says, hey, assert that this arena actually does dynamically grow, you know, because otherwise you're going to get errors potentially. Well, maybe not, because you'll never look at the footer. Yeah, all right. Forget I said anything. Forget I said that. So when we compile this, in theory, we should run just fine right up to the same place that we had our assertion before, because we haven't actually changed anything. And we do, so that's good. But now when we look at our begin temporary memory, end temporary memory, now we should be able to do a better job, right? So if you take a look here when we do begin temporary memory, you can see us doing our thing. If you look, the thing that we're keeping now is not sufficient information for us to be able to restore. Now, there's two ways that we could do this. And it depends on whether we care how much space we take up on the stack, right? I don't think we probably do, so we'll probably just take the easier way and say, well, save the base pointer as well, right? Because we save the base pointer and the used, then we have no problem, as you'll see in a second. But bear in mind, you wouldn't actually have to save all that. You could, if you wanted to, just save one thing, which is the pointer where you're at right now, and then that will give you all the information you actually need. Either one, six of one, half dozen of the other. So anyway, when we do begin temporary memory, what we do now is say, OK, store the base as well, right? Totally fine there. And then what we do is say, when we do an end temporary memory now, we have an additional piece of information. So what we could do is, now that we have our arena, we can do a while loop to hunt back for the base pointer that we actually wanted. So we can say, oh, OK, take a look at the arena and see if its base pointer equals the base pointer we were expecting. If it doesn't, then we know we're in the wrong block, right? We're not in the correct block. I'm sorry. So if it doesn't, you know, if they don't match, we got to go back a block. So now we can say, well, get the memory footer, right, from our arena. And now we want to essentially unwind, like we want to pop back a block, right? And in fact, what we could do is actually make a function here called popBlock that actually does exactly this operation, right? So we could say, all right, if we had a memory arena and we told it to pop a block, then what we do is we just keep popping until we were done, right? And maybe I'll call it free last block or something, just to be clear on what it's doing. So that's going to get the footer, right? It's going to take a look at that base pointer that we currently have, and that's, whatever the base pointer is that we currently have, that's the thing we want to free, right? So we're going to take a look at our current base pointer. We're going to take a look at the footer, and then we're going to say, all right, the footer is going to overwrite all the values in our arena. Make sense? And that's all we're going to do, right? So now the question is just how do we get rid of the old base pointer's memory that we were using? Well, that's not particularly difficult. After we do this overwrite, so we know that we've used all the stuff in the footer that we need. The footer is now invalid if we free it, but once we free it, it's going to be invalid. So we have to pull the information out first. But once we do pull that out first, we can do a deallocate memory call and just pass that pointer, and that will eliminate the block, right? Okay, so this will just walk us backwards, and hopefully it will just walk us backwards to the place we want it to be. Then we can proceed exactly as we would have, because we know we're actually in the same block that we originally took our temp memory sort of snapshot of, right? And so now we should be at the point where we're totally running exactly as we were before, right? So now we can go across dynamic allocations and still rewind our temporary memory just as we were. And so just to do a quick spot check, we want to make sure that we're not leaking anything here, because we might be, but let's take a look. You know what? This is not what I want to see, though. I need more information. Isn't there virtual memory bytes? I don't want the working set. I want the entire pool. All right. Tell you what. Let's just go to perfmon. We'll just go to perfmon. Why not? I don't know if I've ever used perfmon on the stream before. Perfmon is perfmon. Perfmon is a little utility that ships with Windows, and it allows you to access the performance counters in the kernel, among other places. And so what you can do is you can run it. You just, like I said, Control Escape, however you run programs, type in perfmon, and you get this guy, and it comes up with a view that's not particularly useful. It's percent processor time, but I don't care about that. So I can get rid of it just by hitting the X button, and it'll eliminate what's in there. I can then do an add. Use the add button and say, I want to look at a particular process. And you can go down to wherever that is. There it is, process. And you can look at stuff like virtual bytes. How many bytes of memory has it allocated total or whatever, right? And I can also similarly look at the working set bytes. Where is the working set bytes? There it is, right? So I can look at both of those. And then I can select in this instances thing, I can select our application, Win32 Handmade, right? And I can say add. And then I can get those. Oops, I don't need the total. There we go. And so now I have both of those for my application, right? And you can see those listed down here. Now, if I just click on them, I can see exactly how much memory I am taking. And I can watch it doing its thing, right? And so you can see minimum, maximum, right? And I can see that it's stable, which is what I want to see. Like I want to see it not changing, and it's not. So that's good, right? I want to see those numbers not going up, so I know I'm not leaking anything. Now what you'll notice is we're not getting a graph up here. Because this thing was made so long ago, if you actually use the kind of amount of memory that a modern application would typically take for like a game or something, the scale is set totally wrong. And so you have to kind of bring it down to a level, right, that you can actually take a look at. There we go. So there's the working set. There's the virtual bytes, right? And that it's kind of cool. Like you can actually save the settings here, but you can see that it'll just graph these for you, and it'll stay up and running and collecting those reports for all the time. And you can just kind of like minimize it and go back and look at it whenever you want. So it's pretty handy, actually. It's a pretty nice little utility to use. Anyway, so I just wanted to verify that. OK. So that's all well and good. Let's just take one more leap while we're at it and turn our entire game over to just dynamic memory, right? So now we'll actually go ahead and go full bore. We will not have any more. Let's see here. Yeah, we'll not have any more block allocations at startup at all for the game code, right? So it's just be. What do we call that permanent state? What's it called? Is it just game state? I don't even remember. It's been so long. Game state. We'll get rid of these entirely. And we're just going to do exactly the same thing I did before, right? So we go to the permanent storage size is initialized kind of stuff, and we just change the way that works. So now we get rid of that, right? And we say, all right, here's the game state stuff. And we look again to see, is it initialized? If it's not initialized, we bootstrap it. What's the arena called here? Total arena? So we've got total arena. I don't know if total arena ever even used? Total arena is not ever used. It's just these other arenas that are used. So we're not even going to do that one, I guess. So we'll just say, is there? I guess it never saves that arena. There's just an audio arena and a mode arena are the only two things. I don't really know why that is. But it is. All right. Anyway. Either way, I'm going to initialize the game arena this way, like that. And I'm going to get rid of all of this. And then instead of doing sub-arenas, I'm just going to let those guys, since this will get cleared, I'm just going to let those guys be dynamic as well, right? Make sense? So now everything in our game is running through dynamic allocation, right? And again, I just wanted to kind of emphasize this. Well, I guess not. We still have to do, there's probably a sub-arena call somewhere. Is there? Yes. So there is a sub-arena call right here. So we'll have to deal with that. Well, not really, I guess. Sub-arena, memory arena. This one, I guess. There you go. So we still need to do something with this guy. We can have the world arena also be similar. We would just have to have it be cleaned up, right? It would have to actually clean itself up. All right, so we'll talk about this in a second. But what I wanted to point out here was just that, as you can see, most, like 99% of your code that uses arena doesn't really change at all if you're using fixed size versus dynamic allocation in terms of your arenas, right? It just isn't a particularly, it's not particularly important thing in terms of knowledge in most of the code. So it's really all of the same principles that we have been applying, they just work for the most part pretty much throughout, except for things where you ask the parent arena how much size it has and then use that much size, right? That's the only thing, and we're seeing that here in this sub-arena, right? So what we want to do here is say, well, OK, when we do create world, what we probably want to do here is, again, we could just make this be also a dynamic thing and allow these arenas to be dynamic as well. What we do need to, again, appreciate is if we do that, so if we use subarenas that would have had to get cleaned up, right? We have to be aware of that. So we'll take a minute to go do that. How much time do I have here? I've got 15 minutes. OK. That should be plenty. All right, so temporarily what we'll do here is we'll just say, like, OK, the world arena also is a thing that can just be kept as dynamic, right? So if we wanted to make the world arena be dynamic, all we have to do there is say, like, OK, don't bother actually pushing that thing on at all, right? Just leave it as cleared, because this will clear it, and then it will be a dynamic arena with the default size. OK. So the only problem we would then have is that we don't ever clean up that particular memory, right? That memory is never going to actually get cleaned, because when that arena gets pushed, essentially gets pushed on here, there's never anything to tell that arena to clean up if we were to unwind this structure. Now, I don't actually know exactly how we were doing this in the past. I'm not sure what we did. Oops. What we were doing about that. So, like, for example, when we are in handmade.cpp, when we launch a game mode here, how do we actually do that? Because somebody's got to deal with this somewhere. But I don't know where. Should be here somewhere. Play world. So you can see set game mode. Where is set game mode? There it is. So this is our problem. Right? This is our problem right here. So basically what happens is if you try to do subarenas like that and you then go to clear out one of your arenas, those subarenas aren't going to get cleared, right? They're never going to actually get cleaned up. And so what we actually need to do there is we need a system whereby we don't rely on that, or we bake knowledge of the fact that there are arenas spawned off of other arenas. We bake that into the memory system. Now, at the moment, it's probably just not that necessary because we don't have that many memory arenas, right? There's just not that many of them. Let's see here. These are all pointers. One, two, three, 4, 5, 6, 7, 8, right? So there's only 8 of these things total. So at that point, right, it's kind of like, do we really even want to bother with that? And some of them are in systems that don't have any of these properties, like the task with memory bit, where it's just not relevant, right? It's not a relevant thing. I don't know. Does task with memory? Do we actually even use that? By the way, I don't even remember if that's actually used now. I'm curious to know. Is it? Let's see. I'm going to move over here so I can not be behind my own head. Yeah, so this is just game state. And this is all goes away, right? think that's it. All right. Perm arena. Where is that coming from? Just want to take a look at this. Ah. Yeah. Just for the record, when you do a bootstrap and you want to create a new struct, it helps, you know, don't want to be pushy about it or anything, but it would help if you would actually record the thing you actually created. Just, you know, just good to know. All right. So we do have some problems here, though, that we have to take a look at more specifically, and that is that, again, that subarena part isn't going to work. So, well, I guess since we might as well, since we started here, I will go ahead and finish getting this guy going, but then we'll take a look at the subarena stuff. So this is fine. I assume the audio state is now set. Oh, and we have to record that in the memory structure as well. There we go. So in theory, we should bottom out now because we're not handling that subarena call, but I guess it's okay. I just wanted to see if that would work because it will still use the rest of the megabyte part that it had. So yeah, suffice to say. Let's take a look. So if I go into world, if I go back into world mode, or sorry, world, where I do the subarena call, or at least I thought we were doing a subarena call. There we go. Let's see. So these are task arenas out of the transient state. And again, I don't think we actually care about that at all. So in theory, when we do this task memory here, when we go through these tasks, each task is going to have been cleared to 0. So these would also all just work, right? Yeah. And I think that's it, right? So now, really our problem that we have at this point is strictly that our clears wouldn't work anymore, right? So even for like these tasks, right, now the tasks have arenas that will dynamically allocate for them, and that's all well and good, but when they go to clear, like our clear call will never actually work, right? So for example, this clearing of the mode arena will not actually clear all the memory for the mode arena. And is that the only time we ever clear? Do tasks not clear their memory? I guess, do they just use temp memory? Maybe they do. So here's where we do begin task with memory, and temporary memory flush. And yeah, so actually they just clean themselves up exactly that way. All right, so that's pretty easy as well. So yeah, okay. So I guess that's all well and good. So our clear now, I guess the point I was trying to make before though is our clear, which we do need for certain circumstances, our clear doesn't work, right? Because if you look at what clear does, clear, all it does is wipe out the state. But wiping out the state isn't what we want to do here because we may have allocated a bunch of blocks, and we don't want those blocks to stick around, right? So what we want to do when we say clear is we want to be able to do essentially free last block all the way up to the original block, right? We want to basically clear out everything all the way to the original block. Now, I don't know if initialize arena here, I don't know who's calling this at the moment. But what you'll notice on this guy is that basically when we do this initial call here, in fact, does anyone call this? Let's just find out. Hey, look, let's make this our first growable arena. Well, we didn't do that. Oops. It is now. There we go. So basically, nobody uses that form of initialize arena, right? Except for our clear call, which we just said we don't want. So that's good, because now we can basically say, let's just get rid of that, right? Let's just say we just don't have that anymore. So the only time you would say initialize arena is if you wanted to set the minimum block size for it, right? And so what I might do is just say, let's just say that instead what we have is just a set minimum block size. Like so. And that way we can just search for that going on. And that's it. And no one's actually even doing that at the moment, right? So we probably don't even really need that. OK. So now everything's working there. The problem is just we need some way of actually doing the clear. And what I'd like to do with the clear is I'd like to say, OK, if we're going to clear this thing, then what we want to do is we want to essentially rewind back to some point where we know we've gotten to all of the memory that we may have allocated has been cleared, right? That's what we want to do. And so we can do this relatively easily just by tracking one additional parameter, right? And that parameter is just how many of these things have we allocated so far. So in our memory arena, right, all I have to do is like block count, right? I don't know why that's an S32, but OK. Or a U32, I should say. So if I just track how many allocations I have made, then I know when I got back to my original block count, when I got back to my first one. That would allow me, even in the case where I put on a block that someone else had allocated or sub-allocated out of someone else's block, I could still just not increment the block count at the beginning for that case, and that would allow me to always clear back to anything that I had allocated, right? So in clear, all I would have to do is do while the arena's block count is greater than 0, free the last block. And then in here, what I would do is say, OK, when I have done that, just decrement that block count. So now I know how many of these things deep I am. I know I can always free back to the beginning. And so all I have to do is increment that anytime I actually did an allocation of some kind. So the arena's block count will always go up whenever I've made a new one. Make sense? So now our clear actually works just fine. But again, we still have one more problem. Like, in theory, we should still run OK. But we still have one more problem, and that is any arenas that we were previously thinking of as kind of ganged to other arenas aren't going to work. And so what I'd like to do is let's just not do that, right? It's easy enough for us not to do that, so we might as well just not, right? So if you take a look at the places where we actually care about that, they are pretty few and far between. Mostly we just have arenas that just stay around all the time. And so when we actually do need to clear something, right, we know that that's a very rare, actually. So we do this clear of the mode arena. And so really what we want to do is say, well, that mode arena bit where we did sort of the world's allocation stuff, What we could do there is the world really doesn't need probably its own sub-arena for modes like that, right? We could just have it use this arena. So if you take a look at what happens in the world, and it's got this extra arena here, what we could just say is like, hey, just use the arena that the person passed you. There's no reason why you need to be a separate arena. Just have the person tell you what arena you were going to use, and then be done with it, right? I can't see anything. That is not helpful. I need to add a mode to 4Coder that's like stream mode, which tries to keep things in the center of the screen. So now it's just going to use that arena all the time. And so now when that's cleared, right, we should get a crash immediately because it's just pointing to 0, right? So all we have to do now is just say when we actually create a world, just point it at the arena we're given. Don't try to sub-allocate out of it, right? Because why not? So if we do that, let's see here. I don't know why we weren't doing that to begin with, to be honest. Even in the other case, I'm not sure why that would have been. Yeah, so somewhere where we do world, where we initialize the world, create world. There we go. And so now that should be getting cleaned up. So if we're doing modes here where we swap back and forth, like here's the title mode thing, and this is the thing that will like play the cutscenes or whatever else periodically and that sort of thing. Or not. What happened to our cutscene? Our poor cutscene is gone. Is that when we changed the camera code? I thought we looked at that when we changed the camera code. We'll have to add that to the to-do list. Well, anyway, now we're running entirely on the dynamic memory. And so if we take a look at how much memory we're actually using now, it should be significantly less as well because we're not actually allocating space for stuff that we don't need at this point now, right? So you can take a look at where those lines went, right? They dropped quite a bit further down. So if you take a look at how many bytes we're using under a gigabyte now because we're not actually doing any of that load. Now the other thing we can do is I believe we're actually doing in the asset system, I believe it manages its own memory, right? And so it does sort of a thing where it just does a big old allocation. So that part where we passed the size here, which is I think 256 megabytes or something like that, that's still getting a pretty big chunk of memory taken out for it, and various other things as well. So we could probably stand to start doing a little bit of a memory profile at this point, but maybe we'll save that for next week. Anyway, that's the first part of our memory upgrade. And like I said, now it's all working relatively well, but the main thing that we have to do, besides sort of going in there and fixing some of those, now that we have this ability and we can make it a little cleaner, we can probably reduce the need to have like multiple arenas for any particular reason now. Like we don't need a separate audio arena probably. Or maybe we do, but it would, again, be its completely separate arena potentially. If I do loop live code editing, you'll notice that nothing happens, right? And the reason for that is just because we now no longer have a way to track any of those arena blocks we allocated, so they're not actually getting written. So let's go ahead and do here cutscenes now malfunctioning. Actually, I guess we'll just we got to do a debugging day so we can do these guys. So we probably need that and like a clean up where arenas are used and how. But that's about it. So we'll go to the Q&A here. I don't want to go too far over time there. So we'll go to the Q&A. But now I believe we're at least fully dynamic in all the ways that are not related to debugging. So the loop live code editing is obviously a debugging feature for our purposes. So we want to support that just for ourselves, but it's not a user-facing feature. So we've already done the memory arena stuff that's actually necessary for us to ship, right? To actually, if you want to ship a game with dynamic memory allocation, we've already done that part, right? And so, yeah. Zularesco, have you ever tried reserving a very large amount of memory and then committing memory as needed so the arena can grow without the base pointer changing? Yeah, well, I mean, yes, I have done that, but I've never shipped that in anything. So if you can guarantee that you're running 64-bit only, if you're running 32-bit only, that won't work. Right? And the reason that won't work is you'll never be able to reserve a big enough region of memory in 32-bit to allow all your arenas to have enough size to grow if you don't know ahead of time how big they have to grow, right? But if you're on a 64-bit system, then you probably can. So that on 64-bit, a code that only has to work on 64-bit, that might be feasible, right? It largely depends on how the operating system plays well with you. Dude in basement, thoughts on placing the footer at the beginning of the memory arena so bad coworkers don't overwrite it because it is at the end currently. Well, if the coworkers would write off the end of the memory block and crash potentially if you moved it to the beginning. But sure, yeah, you can if you want to move it to the beginning. The reason that I don't like moving it to the beginning is because it means that your first so it means that your initial thing that you're pointing to is actually not at the base of the memory block, if that makes sense. Which I don't always like because you may want that to be aligned to 64K boundary or other things like this for usefulness pointer-wise or who knows what else. So I usually put them at the end, but yeah, you can put it at the beginning if you want to. There's no real fundamental difference between those two things. As I'm saying that now, I'm thinking, wait, is there though? I mean, basically, here's all I'd say. So let's say you needed to be aligned to something large. So let's say you're using 16. You're on like a really modern machine. So you're using 16 wide SIMD or whatever, right? So you're like 64. You're like one whole cache line is the alignment boundary you were looking for, right? What it means is you'd have to basically take 64 bytes at the beginning of your thing for the header, because if you didn't, then the first piece of memory wouldn't be aligned to that. So you're going to blow 64 bytes worth of space at the beginning of your buffer regardless. Now, if you don't mind that, then that's fine. But if you do, then you kind of have to put it at the end, because putting it at the end is the only way you can ensure that, hey, because it only needs like 16 bytes or 32 bytes or something, it's the only way you can ensure that you're not using more than you actually needed. Other than that, I don't think there's any real reason. But maybe there is. I don't know. I'd have to think about maybe it isn't. M1EL, you spend so much time on memory management. We do? If programming games for Windows, Linux, would it be better to use malloc and then create custom allocation for hot parts? We don't spend any time on memory management, do we? This is one of the first streams we've had in, I don't even know when, where we even touched the memory. Let's see. Casey, how strict are you on minimizing the amount of memory that is used by the game? At the moment, not really. Like right now is not really a particularly useful time to minimize the amount of memory used by the game, in my opinion, because you kind of are wasting your time if you try to prematurely optimize memory usage. So we don't do anything, I wouldn't do something that I thought would be impossible to optimize later, right? But as long as it's something reasonable that I'm not too scared about, we just do it and don't care too much about it here, because I'm assuming that we will do, much like performance optimization, we will do those more towards the end of the project than the beginning. And then at the end of the project, we may do some things where we're like, this is using too much memory, we need to change how we're doing it. And then that will be the time for that. And yes, Sean McGrath, the event tracing for Windows API is like the worst API ever made. I mean, that's why I said that. It just keeps getting worse the more you want to do with it. Keep in mind also, at least if I remember correctly, the API badness that I talked about was the API badness you'd encounter to get anything out of it, right? But if you wanted to get everything out of it, like if you actually wanted to go get all of the things that it was capable of getting, there's like a whole other set of disasters you are in for, right? That I never even tried to work with. Miblo says, when we're dynamically allocating, we could potentially end up allocating every last drop of memory available to us, right? Are there situations in which we'd want to make sure we allocate some amount less than the max? And if so, how would we best do that? So I guess what I'd say about that is I don't really know of any good way you can do that without just doing it the way we originally did it, right? Like, when we just allocate memory at startup and only use that memory, that's the only way I know of that you can actually guarantee that you'll run properly. If you don't do it that way, then you never know whether some other task in the operating system, it's like a race condition kind of a thing. No matter what you try to do, you can never know ahead of time how much memory you might have later, right? So the only thing you can really do is allocate, and then when you fail the allocation, then that's it, right? And it's usually pretty infeasible to try and make a well-working application that actually handles an out-of-memory error anywhere in it correctly, which is why I try not to do that, and I tend to do pre-allocating upfront kinds of stuff for any situation where I'm actually concerned about it. So yeah, there really isn't. I mean, there really isn't a way to be able to predict whether you're going to run out of memory or not, other than just allocating what you want up front and then using that. That's really it. And yeah. Some people think by putting in a bunch of exception handling and smart pointers and all sorts of stuff that they will properly handle out of memory errors. I've literally never seen a single time when that worked. So the only way that I ever know that actually works is allocate up front and don't use more than what you were able to get at the outset. Long Boolean. So currently, you can only free memory in the last memory blocks. If you wanted to free stuff to the beginning of the arena and keep the stuff at the end, you would need to do things differently. Yes, obviously. These are arenas that are, they're really not technically arenas per se, because I think, I guess what I would say is arenas are used to describe a different type of memory pattern as well, which is when you just do regular variable allocations and can free anything you want inside them as well, but then there's just a flush command that frees everything. These support that, but not freeing out of the middle. So they do support the get rid of everything, but they don't support like sub-freeing. So really these are more like stacks. I mean, they're really more like memory stacks, you know? And so if you want the ability to dynamically free arbitrary stuff out of the middle of one of these arenas, yes, you need to then have a general purpose allocator, right? Which you can implement. It's not like super hard to put one on top of this, but it's no longer a straightforward, like just push the pointer forward thing. Slurrisco, if you're planning on large worlds, are you planning then on compressing and decompressing from the mandala on the fly? No, so keep in mind that we already could support out of core trivially if we wanted to. I don't know that we need to ever, because the chances that we could create a world large enough to not fit in physical memory on today's machines seems low. But bear in mind that this stuff right here, this itself is where we would put the inside the world thing is where we would put the streaming to disk. So we would not implement the streaming in the memory system. We would implement the streaming in the world struct. So basically, when you do sort of these chunk access stuff, when you stream in and out of chunks, that would be where we would put the out of core stuff. Will Handmade Hero use texture compression in OpenGL? Probably not, because it would only result in degraded visual quality, right? The reason you turn texture compression on is either because you need more texture bandwidth through the card, or you need to save texture memory space on the card. But Handmade Hero, since we know what we're looking at and we have a dynamic paging system for textures, should never need those things. So all it would do if we turned on texture compression OpenGL, just make all of our textures look uglier, like right. So it basically that would be a button that was called like make my artwork look worse, which we wouldn't want to do. So no, I suspect we would never turn on texture compression for Handmade Hero because it seems like it would be strictly a lose for us. And yes, like I was saying earlier, Pseudonym 73 was posting about the term arena. So like I was saying earlier, the reason why I say that these are more like memory stacks than arenas is just because arena is not a word for exactly the structure that we have here. Arena just refers to the fact that memory allocations were being tracked as a group so that they could be freed as a group. It does not imply that you can't free individual ones, right? So. All right. So I think that's about it. I'm going to close up. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. It comes with a source code so that you can experiment with it. We also have a forum site you can go to if you want to ask questions, a Patreon page you can go to if you want to support the video series, a schedule bot that tweets the schedule all the time so that you know when we're going to be live, and an episode guide if you want to catch up on old episodes. That's it for this week. We'll be back next week for more episodes of Handmade Hero. For the schedule, do check the schedule bot. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.